Good evening, good morning, good afternoon, depending on your different time zones. This is statistical and geospatial inside YouTube. We're meeting in lesson number 40B, which is about analyzing Likert scale in the SPSS. The purpose of this lesson is to enable you to calculate the range for each one of the Likert point and also to enable you to explain or to interpret the Likert output in the SPSS. Last time we converted the Likert questions output into, first of all, we converted it into interval data. Let us go and see where are these data. So we converted the Likert question. These are two here. You can see we converted them into scale question. So in the data view, you can see these are the two scale questions for satisfaction and the likelihood. And after that, we converted these two scales into descriptive statistics that can be described by the minimum and the maximum and the mean and the standard deviation. Okay. Now, for us to have a meaningful interpretation of this minimum maximum in the context of the points of the Likert, like extremely dissatisfied, dissatisfied, neutral, satisfied, extremely satisfied, it will be very difficult for us because you don't know when we say the minimum number of the respondents. So this minimum number, did they answer by extremely dissatisfied or dissatisfied and etc. For this reason, we have to find the ranges, and the range that we're going to calculate will help us to actually position each one of these 5 points, whether to be in the minimum or the maximum or the mean. So to do this, first of all, I've prepared something in Excel here. So you have, when you look at the two questions, the first one was question number 5 was about satisfaction, and question number 9 was about the likelihood here. So each one of these scale is made up of 5 points, 1, 2, 3, 4, 5. So it means that the maximum range of the points of the scale is 5, and the minimum is what is 1. Then you have to get the difference between 5 and 1 is 4. This is the first thing that you should do. Now you have, let me try to close this one here. Yeah, so the difference between 5 and 1 is 4. Then you calculate the difference percent. 4 divided by 5. The different percent is 0.8. And usually we have a factor of 0.1 that we're going to add as we are moving from any one of these points to the next. Okay, for the first point, which is not at all likely or strongly disagree, here we're going to see which we're going to actually calculate the minimum. So this one is supposed to be minimum, sorry. This one is minimum. And this one here is maximum range. Maximum. So for this one, the first here, the minimum is 1. This one here is the minimum. Then what about the maximum? The maximum is this one plus the difference between the maximum of 5 and 1%. So this difference percent here. So the range for not at all likely or strongly disagree, this range is 1 to 1.8. Then you come to the next range, the next one, not likely or disagree. what do you do here? The minimum for this range is the maximum of the previous plus the factor, that is 1.9. And then the maximum for this range is the maximum of the previous plus the difference percent. So this range here is 1.9 to 2.6. Then you come for the third point on the scale. For this one here, the minimum for this is the maximum of the previous plus the factor, which is 0.1. And then the maximum for this here is the maximum of the previous plus 0.8, which is the difference percent. So this range here is 2.7 to 3.4. Then you come for this, you come to this likely or agree. So the minimum here is the maximum of the previous plus the factor, which is 0.1. And then the maximum range here also is the maximum, this is the maximum of the previous plus the difference percent. So here you have 3.5 to 4.2. Then the last one, which is extremely likely or strongly disagree. So the minimum for this is the maximum of the previous plus the factor, which is 0.1. And here, the maximum here is the maximum of the previous plus the difference percent. So here, the range is 4.3 to 5. So I've transferred them here. For example, in this case of the satisfaction quotient, you have extremely dissatisfied is 1 to 1.8, dissatisfied is 1.9 to 2.6, neutral is 2.7 to 3.4, satisfied is 3.5 to 4.2, and extremely satisfied is 4.3. Sorry, is 4.3 here, 4.3 to 5. Now, by looking at the descriptive statistics, the minimum is 1.6. You find where does it fall. 1.6 is 1 to 1.8. So 1 to 1.8 is 1.6, which is the maximum. It is what extremely dissatisfied. So now what do you say here? You can say that the minimum number of respondents are extremely not satisfied with the quality of the products. Then you come to the next one, which is the maximum, and the maximum is 3.20. So the maximum 3.2 falls here. It falls between 2.7 to 3.4. It is neutral, and this one is the maximum. So what is the explanation for that? It means that the majority of the respondents, which is the maximum number, are neither satisfied nor dissatisfied, because neutral here, these are the people who did not give their opinion. So they are neutral. They actually prefer not to say anything. So they are neutral. So these are the majority of the respondents. They are the majority, they are the maximum, they are neutral. Then you look at the mean. Look at the mean here. The mean is 2.34. Where does it fall? 2.3. So I think 2.3 falls here, 1.9 to 2.6 in this range. So this is the range of dissatisfied, and this is the mean. What does it mean? It means that the average number of respondents are dissatisfied, means they are not happy with the product, with the quality of the product. So these are actually they fall here, which is the mean. Mean is the average number of the people. Again, you come and then you look at the standard deviation. The standard deviation is 0.550. It is very small, it is less than 1. This means that the data points clustered closely around the mean. In other words, it means that most of the respondents share similar opinion of being not satisfied with the quality of the products. Then, what is the lesson learned for the industry? The food processing industry will have to improve the quality of their products based on this survey. Then the next one is we're going to see for the questions of the likelihood. For the question of the likelihood, of course, we start by looking at 1.6. 1.6 is falls between 1 to 1.8, which is the minimum. So here you can say the minimum number of the respondents express an opinion of not at all likely to recommend the products to others. So these are the minimum number of people who fall within this category. The next one is 3.20, which is the maximum, and you can see that 3.2 falls here. 3.2 fall between 2.7 to 3.4. This is the range for the somewhat likely. Somewhat likely. So what does it mean? It means that the maximum number of respondents, which is the majority actually, they're hesitant. They're hesitant to recommend the products to others. Yeah. So the mean is 2.2, 2.22, which is it falls here. So it falls in the range of not likely. This is the mean. So what does it mean here? It means that the average number of respondents are not likely to recommend the products to others or may even discourage others to buy the product. Then we come lastly to look at the standard deviation. The standard deviation is 0.476, which is smaller than 1. So it shows that the responses are clustered around the mean. And again, there is a high consensus among participants because most participants share a similar opinion, which is falling between not at all likely and not likely. Again, here, the industry should learn a lesson and to improve their quality. So that, of course, such surveys are very important because it will help the management to do something about what has been said. Okay, now we've been able to give explanation to the Likert points in the scale based on the descriptive statistics. But this does not mean that we cannot use non-parametric tests to analyze the Likert scale because the Likert is ordinal, which is non-parametric. But still, we have some tests that we're going to see. Again, the purpose of converting the Likert scale into interval is to allow for parametric tests to be used. Now we're going to use some parametric tests to analyze it. So first of all, before we use any test, let us know whether our these data are normally distributed or not. To do this, we are going to look at a test of normality. And this test, there are two tests. One is called Kolmogorov-Smirnov and Shapiro-Wilk test. So for Kolmogorov, your sample size or your cases must be greater than 100. And for Shapiro-Wilk, you have samples which are less than 100. But the normality assumptions are the same for both. It means that your test should not be significant. It means that the significant level should be greater than 0.05, the one that we're going to calculate. And the next one that we're going to look at the normal distribution curve. So these two will give us an information as to whether to continue with the parametric test or not. So we're going to start by looking at this normality test. We go to our data here. This is our data. You go to analyze descriptive statistics. You come to explore. So you roll down until you get the two questions: satisfaction, the likelihood. Bring them here. For the statistics, there's nothing you can do here. You come to the plots. So what you need in the plots, you need none and normality, these two. Then you say continue, then you say okay. So you have the first table. This table here is giving us about the statistics that we have 10 respondents. All of them fill the questions, none of them miss it. So missing here is 0. It means that all of them answered. Again, in this table here, we can use kurtosis and skewness to know whether our data are normally distributed or not. But this, I'm not going to explain anything about this. We shall look at this one later. Let us come and see our normality test. So for the normality test, you have satisfactions, and then you have the likelihood. These are the statistics, the degree of freedom, the significance, and then you have the significant here. So for the Kolmogorov, we're not going to explain anything because our data is less than 100. I will just concentrate on the Shapiro week here. For the Shapiro week, for satisfaction, the significance is 0.670. 0.670 is greater than 0.05. So it means that there's no significance, which means that of course, our data is normally distributed. The same for the likelihood. The significance calculated is 0.433, which is greater than 0.05. In this case, our data are normally distributed. I told you the other time you can move this table by right click and copy, or you can use the other method that I told you. You can export them. You can export them in any other format that you like. You can export them as a Word document or PDF or even PPT, that is a PowerPoint. So now you have seen here that this one actually tells us that the data are normally distributed. Then we go again to the next one. Remember I told you, I say I have two. You have the Kolmogorov-Smirnov and Shapiro-Wilk and the normal distribution curve. So I'm going to look at the normal distribution curve. You go to the data here. You go to analyze descriptive statistics. Okay. Then this time I'm coming to frequencies. Then I go down. I move all this to here. Then for the statistics, there's nothing we can do here. Let me come for charts. For charts, I need histogram and this show normal curve, these two. So continue, okay. So usually we have such information which are telling us about your data. So I will just go direct to the curves. You can see the satisfaction. Our curve is normally is telling us the data is normally distributed, though we have some issues, but it has accepted it within the limit of statistics. Then for the likelihood also, uh, there is distribution, normally distribution, so our data are normally distributed. From here, what is coming next is that we have to proceed to the parametric analysis. We're going to parametric test. We're going to use what is called the t-test uh, for uh, uh, for independent samples, for two independent samples t-test. First of all, let us have some assumptions about our data. So you have to state some some hypotheses. For the first question was asking how satisfied are you with our products? Then let us look at the null hypothesis, because we are going to look at the male and female as regard to their opinion about the quality of the products. So the null hypothesis usually is a hypothesis of no, of none or not difference. We don't have any difference here. So we can say there is no difference in the level of satisfaction for the products between the male and the female customers. It means that male and female, they could have the same opinion as far as the quality of the product is concerned. In this case, the means of the male should be equal to the means of the female. However, in the alternative hypothesis, we say there is a difference in the level of satisfaction for the products between male and female customers. So in this case, uh, the mean for the male could be greater than the one of the female, or the one of the female could be greater. So we have a two direction hypothesis about that. Do you remember? This one is called two. Uh, yeah, we are actually two tails. This one is called two tails, two-tail hypothesis. I think in one of the lessons I had explained it clearly, and then we had some examples that told us about this type of hypothesis and the differences. We had some examples in public health and in education and etc. Now, this is for the quality, for the satisfaction. Then question number 9 was, how likely are you to recommend our products? Again here, the null hypothesis is saying there is no difference in the level of likelihood for products recommendation between the male and the female customers. Whereas the alternative is telling us there is difference in the level of the likelihood for the product recommendations between the male and the female. So immediately after this, we're going to do the test. So you go to where the data is, you go to the data, you come to analyze, this, compare means independent sample t-test. Now you come down to where you have these two data here. You move them to this box for the option for the statistic. The most important thing is that the confidence interval, which is 0.95, that is 95%. Then we say continue. What is very important here again, you move your agenda. You move the agenda here. You have your agenda. I move it to this grouping, and immediately it's asking you about the grouping of the gender. You remember we say one was male and two was female. Then we say continue. Say continue. Okay. Then you say okay. When you look, let us, I have moved this document, I brought them to the PowerPoint here. So here, this table is telling us about the statistics. There were 5 male and 5 female in each test or in each questions. And the mean, when you look at the mean more or less are the same between the male and the female, and also the standard deviations, okay, and the standard error. This one alone, of course, can give us information that there's no difference, but still, we have to go and look at the statistical difference in the test of the two independent samples. Now, when you look at this test here, you have, first of all, Leeuwen's test of equality of variance. And this test must not be, the significance must not be, it must not be significance. So usually there should not be difference between the two variances. Like this, one is greater than 0.05 for both satisfaction and the likelihood. From here, we can proceed. When you look at the mean, more or less the means are the same. But I'm very much interested at what? and the significance. For the satisfaction, the significance is 0.596, and 0.596 is greater than 0.05. And for the likelihood, the significance is 0.385. Again, 0.385 is greater than 0.05. So what do you conclude? You conclude that there is no difference. So now we go back to our hypothesis here. For the first one of we are going to accept the null hypothesis of no difference. We are going to reject the alternative hypothesis. Why do we reject the alternative? Because we have enough evidence to support the null hypothesis, whether for this question or for the other question. I think up to here, I've come to the end of the today presentations. Please, you subscribe to the YouTube channel so that whenever new videos are uploaded, you will be notified immediately. Thank you and see you in the next video.